Now see, so in this video I am going to explain about final value theorem. Here the final value which is x of n, here the final value is nothing but infinity. Initial value is 0 and final value is infinity. So the statement for final value theorem is x of infinity is equal to limit z tends to 1 minus z inverse x of z. So let us take x of n is a one-sided signal defined in the range n is in between 0 to infinity. Now, so this final value theorem which is very important in the exam point of view. Now let us see the proof. Now take the Z transform equation, that is Z transform of x of n is equal to what? X of z, that is equal to summation n is equal to, I am taking here as single-sided signal, that is n is equal to 0 to infinity x of n z power minus 1. So now in place of x of n, I am substituting x of n minus n minus x of n. So the Z transform of x of n minus 1 minus x of n is equal to what? In place of x of n, you have to substitute x of n minus 1 minus x of n into Z transform. Let us consider LHS. Here LHS is what? Z transform of x of n minus 1 minus x of n. This is LHS. So we know the Z transform of x of n. The Z transform of x of n is nothing but what? X of z. So we don't know the Z transform of x of n minus 1. Let us find the Z transform of x of n minus 1. So first write down the Z transform equation, summation n is equal to 0 to infinity x of n z power minus n. In place of x of n, so you have to write x of n minus 1, that is x of n minus 1 into z power minus of, in place of n, you have to write n minus 1. Now first substitute the value 0 in place of n. So 0 minus 1 is what? X of minus 1. Okay, so z power minus 1 minus into minus, in place of n you have to substitute 0, so you can get z power minus 1. Here x of minus 1 you have to take it as outside. So after substituting 0, then you get the limits n is equal to 1 to infinity x of n minus 1 into z power minus of n minus 1. Let us take n minus 1 is equal to m. For simplification, let n minus 1 is equal to m and n is equal to m plus 1. Then x of minus 1 summation m is equal to, so here the limits are, you have to again change, when the variable is changing you have to change the limits from 0 to infinity x of n z power minus of m plus 1. Okay, now x of minus 1 plus m is equal to 0 to infinity x of n. So you have to write it is in the form of a power m plus 1. You have to separate a power m into a power n, that is z power minus m into z power minus n. Now you can get x of minus 1 plus summation m is equal to 0 to infinity x of m z power minus 1. So it is in the form of Z transform equation, that is x of z into z power. So now Z transform of x of n minus 1 minus z of x of n is equal to what? So we have already found, find x of z transform of x of n minus 1, that is what? X of minus 1 plus z inverse of x of z minus x of z, that is x of minus 1 minus, so in this you have to common x of z, that is minus of 1 minus z inverse into x of z. Now taking limit z tends to 1. So in order to so in this taking limit z tends to 1. So in LHS x of minus 1 minus, so here z is there, then you have to substitute limit z tends to 1 into 1 minus z inverse into x of z. Keep it as equation 1. Now consider RHS. RHS is what? Summation n is equal to 0 to 1 x of n minus 1 minus x of n z power minus 1. Now on applying z, so just you have to remove this z, you have to apply z tends to, limit z tends to 1 into summation n is equal to 0 to infinity and remaining equation. On applying z to limit z tends to 1, the term z power minus 1 becomes unity. Okay, now so this is unity, remaining equation is what? This is the remaining equation. Now changing the summation index from 0 to p and then take the limits p tends to infinity. So summation index you have to change from 0 to p. Then taking limits p to infinity. So I am taking limit p to infinity, p tends to infinity, summation index n is equal to 0 to p. Here the p value is what? Infinity. So the limits are what? 0 to infinity into x of n minus 1 minus x of n. Now you have to expand this series. First substitute 0 value, n is equal to 0. So that is x of minus 1 minus x of 0 plus, then substitute x of 1. X of 1 minus 1 is what? 0 minus x of 1 plus and so on. Next x of p minus 2 up to p. So you have to substitute x of p minus 2 minus x of p minus 1 and so on. Now, so here x of minus x of 0 plus x of 0 is cancelled. Minus x of minus 1 plus x of 1 get cancelled. So you can get only x of minus 1 and x of p terms only. Now substitute p tends to infinity. So when substituting p tends to infinity, you can get x of minus 1 minus x of infinity. Now equating equation 1 and 2, we get equation 1 is what? This is equation 1. So write down equation 1 which is equal to equation 2. Now minus 1 get cancelled and minus minus get cancelled. X of infinity is equal to what? Limit z tends to infinity 1 minus z inverse x of z. Okay, so that is the final value theorem statement.